today. So guys, computers need to be closed. Headphones need to be off. The notes today, we are going to look at factoring completely. Guys, notes.
Notes? Bless you.
Thank you.
You're welcome.
So factoring completely is the idea that we introduced Monday at the end of notes. Okay, and it's the idea that we don't just want to be able to factor one specific type of factoring alone, but that we want to be given instructions to factor and we want to be able to get any problem factored completely. Okay? I'm not sure why I hear music playing when headphones and music shouldn't be on at all. Okay, so when we are talking about factoring completely, it is going to be our job to decide what way we want to and or need to factor. Just like you did in the POD though. Right? Once you kind of know how to factor, you're going to recognize what type of factoring it is from the start. Jackie, put it on my desk. The first thing that we are going to look for every single time is to see if there is a GCF. So we are given a problem and we are asked to factor it. Our first goal is going to be to see if we can find out a GCF. If there's not a GCF, we skip it. If there is a GCF, we are going to factor it out. Okay, our second step is going to be to count the number of terms.
My rib cage hurts.
Okay, so we are going to count the number of terms, right? We're simply looking at, well, how many pieces are being added or subtracted in it. And you all basically just told me this in the POD, that if we count and there are 4 terms, we are going to want to factor by grouping. Right, factoring by grouping is where we split it in half. If we count and there are 3 terms, we are going to factor it as a trinomial. And that's where we multiply A times C. If we count and there are 2 terms, then we are going to check for a special case. Right? And that's when we're going the route with the conjugates, one positive and one negative. Now, here is the key. Just because there are a certain number of terms does not mean that it is factorable. Okay, so just because you see 2 terms does not guarantee that it is a special case. It's still going to have to meet all the rules and requirements that we've been talking about for 2 weeks. Okay. Remember, when I am putting this on the scale of importance, being able to factor is important. Okay, it's not always as important that we can get something factored completely. Sometimes we just maybe need to consider a couple types of factoring because we're going to use it in our next unit as we start solving. Okay, so whether or not something is always fully factored might be different than just being able to get a couple of things factored out. Okay, so I sort of put this in the world of like, okay, we need to know it, but it's not high up there as important as some of the other pieces. Okay? So here we go.
Is this an example?
Uh-huh. Two y squared plus 14y plus 24. Okay, so let's talk about how we want to factor this. If we had just looked at this and this was the POD 5 minutes ago, what would we probably be tempted to do? Right? A times C. And A times C is not wrong. Mathematically speaking, you're doing correct math. But let's go by our new rules. Okay, so step 1. Is there a GCF?
Yeah.
Yes. What will go into 2 that will also go into 14, that will also go into 24? 2, and so we can factor out.
Alright. Did you get that because of this class?
No.
What? Did you get that because of this class?
The stress ball.
No, I found it out all
I
day.
think it's 'cause you
Okay, so when we divide by the 2, now we're left with a y squared plus 7y plus 12.
3.
Okay, now really, we still have this GCF of 2 in front of it,
Then you just go back.
right? So now our second step says to count the number of terms. When we go to count the number of terms, we are going to look right here inside of the parentheses. Not the GCF, we're just looking inside the parentheses.
That's so satisfying.
Okay, so how many terms does that have?
2. 3.
3, right? 1, 2, 3. So 3 terms we said we would look at a trinomial. Okay, so 1 times 12 is 12.
Now we make a list.
Multiples of 12, 1 and 12,
6.
2 and 6,
3 and 2.
3 and 4.
4.
What set are we going to pick?
3 and 4.
3 and 4. Can I use the shortcut?
Yeah.
No.
Yeah?
Yeah.
Yeah, because there's a 1 right here in front. Which means I can factor this into a y plus 3 and y plus 4.
What's the answer?
Well, my 2 still comes down in front.
Oh.
That's
a lot of work. They're both.
Okay. Okay, so I'm going to show you. I'm going to show you exactly why.
Sounds good.
So my students then say, Mrs. McKinney, I don't understand. Why would I want to do this when I already have a trinomial to start with? Okay, let me show you. You don't have to write this down in your notes, but let me show you what this looks like if we don't factor out the GCF. So 2 times 24 is 48. Okay, so here's our list. Just stop playing. What are we going to pick?
6 and 8.
6 and 8.
Because that adds up to 14.
Because that adds up to 14. Can I use the shortcut on this one?
No.
No. So this one I have to rewrite into
We'll see.
4 terms. And now I have to split it in half and factor by grouping.
It's a different answer.
Okay.
Oh, never mind. If you
Now, does this have a GCF? Yes.
Oh.
Okay, now, if we're talking about what's a lot of work, which one of those was more work?
That one?
This one, because we ended up having to factor the trinomial the long way.
I get confused, like,
right? And when there's a 1 in front, and being able to factor the trinomial with a shortcut is way easier, right? So if we can factor out that GCF, and that GCF gets us to a trinomial that lets us do the shortcut, even though it might seem for the very start while we're first practicing like more work, it's actually less work in the end, right? Okay, so sometimes when we're doing these steps, we're actually making less work for ourselves. Now, other times, we don't have a choice. Okay, what happens if we are given this trinomial? Nope, 2x to the third minus 18x squared plus 40x. Okay, but if we look at this to start with, is this a trinomial that we can factor by doing a times c?
Yes.
Yeah. Oh wait, no.
Why not?
No, because
no,
this-
because x,
Everything
X over
to
the-
the
Right? This is not in the form ax squared
Yeah.
plus bx, so if we don't factor out the GCF, we're not going to be able to factor this at all. Right? So sometimes it's to make our lives easier. Sometimes it's the only way to get it factored. Okay? And when we get to solving by factoring, okay, if we want to solve, we have to get rid of all of these exponents. Okay? And to get rid of exponents, we have to factor. So what's our GCF going to be? 2x. So that makes this an x squared minus 9x plus 20. Okay, then we're going to look inside the parentheses. How many terms is that? 3. So we're going to consider a trinomial. 1 times 20 is 20.
2 times 10, and then a 3, and then 4 times 5, and then that's it.
That's it.
What are we going to do with our signs?
Put them both as negative.
flip them.
And then 4 and 5 would be your group.
Okay, so this is going to factor into an x minus 4.
Exactly like him.
And we never had to rewrite and factor by grouping and do it the long way. Yes?
So every time we do this, are we just gonna keep the one that's on the outside of the press?
Yes, those outside pieces have to come along, just like when we did the prime factoring, right? If you ended up with a lopsided branch. Here is where my students struggle.
Bro, I don't want to do this.
What are we gonna do?
Nada.
The okay,
Prime.
is there a 1x in front of the 18 or no?
Oh, special.
Right?
Well, what is step 1 always? What is step 1? Is there a GCF?
4.
Wait, so is it prime?
C.
This has a GCF.
Oh, it's 2! Ha.
Es de 4.
Soy mensa. I'm gonna cry.
Okay, so now my students get here and they look inside this and they say, okay, how many terms is this?
2.
2. What should we consider with 2 terms?
5.
No meal.
2 terms tells us to consider what?
Special case.
Special case. So is this a special case?
Yes.
No!
No.
No, wait, can you multiply 2 times 2 to get 4?
Subtraction.
It's not subtraction.
It's a danger.
Bruh.
It's a
Pointing at
perfect.
you.
I don't know.
It's nothing. This is the answer. You just took an assessment where when you factored, that was all you could do.
Yeah.
It's still okay that sometimes that's all you can do.
Well, then why'd you try computers like that?
Yeah.
I didn't. I told you that this is what you do. You
That's what to do, and we all said something. You're like, no.
decided that, oh, I want to keep going, and we don't really always need to.
I feel so dumb for this problem.
Yeah.
Okay, so our objective
doing great.
is to factor as much as we can. And sometimes as much as we can is all we've been doing for forever. It does kind of seem like a mean trick.
Yeah.
It's gonna get a little bit more mean after lunch.
If I become a teacher, I want to do exactly that.